All right, welcome everybody. Today we're going to talk about lesson 39. So just to be clear, there is no new content with today's lesson. I just wanted to work through a couple of multiple choice questions with you and one free response, just to kind of make sure that you're approaching them in the best and most efficient way possible. Keeping in mind, of course, that next year, some of these questions you might have access to a calculator and some of them you might not, because we really are not able to differentiate this year. I just want you to think about how you would approach it either way. So here for number one, find the value of 3 log base 2 of 7 minus the ln of 2. So for a problem like this, you would have to have access to a graphing calculator. But just to point out here, you would not be able to simplify this problem using the properties of logs because one is log base 2 and one is ln, which is of course base e. So you would not be able to simplify, which means all you would be able to do is simply calculate. So I want to point out here that log base 2 of 7, that is the change of base formula. And in order to calculate log base 2 of 7, you would have to do the log of 7 divided by the log of 2. Once you did that calculation, you would multiply it by 3, and then you would subtract the ln of 2. Let me just go ahead and pull up my calculator here just to make sure that you would be able to do that. So on the main screen here, I'm going to go ahead and start by doing my change of base. So I am going to calculate the log of 7. And again, if it opens parentheses, you want to make sure that you close them, divided by the log of 2. Close those parentheses. Once I get the answer, if I don't want to round, which you don't want to round till the end, you can just leave that exactly as it appears. Then I'm going to multiply it by 3, and then I'm going to subtract the ln of 2. Now, just to be clear, you could have done that all in one step using parentheses and just making sure that you type things in exactly. My personal preference is kind of to do it one step at a time, but not rounding any of the answers until the final step. So 7.729 is what I would get if I rounded it. Let's go back and hopefully that is one of the answers. And it looks like the answer is going to be D, 7.729. Remember that when it comes to the AP test next year, they are recommending that you solve non-calculator multiple choice questions with no more than 2 minutes and calculator problems with no more than 3 minutes. So if you're spending much longer than that this year, you do want to try to get a little bit more efficient. In number 2, they give you a function that represents the number of bacteria in a dish T hours after the initial population. After how many hours is it until the initial population tripled? So looking at this equation, B of t, you of course want to make sure you understand which number represents the initial population, which would be 250. If you want it to triple, you would have to take that 250, multiply it times 3, and that would give you 750. So you basically want to set this equation equal to 750 equals 250, and then e to the 0.0693t. Go ahead and divide both sides by 250. That's going to give you 3 equals e to the 0.0693t. That 3, of course, means triple. Double would be 2, quadruple would be 4. So just something to kind of watch out for. Taking a look from here, if you can't do any more algebra, which you can't, you're going to go ahead and take the ln of both sides. So the ln of 3 equals the ln of e to the 0.0693t. Remember, ln base e of e essentially cancels, so you're going to get the ln of 3 is equal to 0.0693t. To get t all by itself, you're going to do the ln of 3 divided by 0.0693. That is really just a calculator issue, making sure that if they open a parentheses for you, that you close it. And if you go ahead and do that calculation, you're going to find that A is a winner at 15.583 hours. Let's say that worst case scenario, you had this problem on the AP test and you had no idea how to solve it. You could, of course, try guess and check. You could simply plug in each of those values and see which one got you closest to 750. Now, again, the reason why that would not be a great strategy is because of the time constraint, the amount of time it would take you to plug in each one accurately. Perhaps you would run out of time. But again, if you had no other option, you certainly could try guess and check. Here in number 3, order the following expressions. Now, again, if you had access to a calculator, that would be very simple for you to simply plug each one of those in. But for argument's sake, let's say you didn't have access to the calculator, or at least you didn't have access to it for the entire time. So for the first one here, log base 20 of 4, again, just to be clear, that is the change of base formula. So in order to calculate the change of base formula, and again, I'm going to kind of need a little bit of extra room here, so let me go off to the side. So that is going to be the log of 4 divided by the log of 20. Enter that in your calculator extremely carefully. Just make sure that's an LOG. Enter that in your calculator extremely carefully, and then you will get 0.463. And again, you should always be rounding from this point on to 3 decimal places. Taking a look at the value in the middle, 2 times the ln of e to the negative 3. Well, because of the fact that this is a ln, you could move the 3 down to the front. So that would give you negative 6 times the ln of e. Hopefully you would remember that the ln of e is equal to 1. So that would give you negative 6 times 1, which means that middle quantity would be equal to negative 6. And then similar scenario in the last one. So e to the negative 2 ln of 4, using the properties of logs, you could take that negative 2 and move it up to the exponent, which would give you e to the ln of 4 to the negative 2. If you have the e raised to the ln base e, remember those essentially cancel, and all you would be left with is 4 to the negative 2, better known as 1 over 16. Better known as, if you convert it to a decimal, 0.0625. So again, just to be clear here, you are comparing the quantities of 0.463, negative 6, and 0.0625. Now, obviously, if you're able to calculate those 3 things, I really see no reason why you couldn't put them in the right order, but let's just be clear. So negative 6 is clearly the smallest value. And again, you're trying to go from least to greatest. So make sure that you are, in fact, answering the question at hand. So that means that your middle value there, 2 ln of e to the negative 3, that has to be the first one. So using a little bit of process of elimination, I could go ahead and eliminate a, c, and e. Then the next smallest value would be 0.0625. So the next one in line should be e to the negative 2 ln of 4. The only one that's left that fulfills that requirement would, of course, be b, which means that has to be my choice. So little combination there of calculations, process of elimination. Again, you just kind of want to start working on these techniques. Just because a question is multiple choice doesn't mean that you should be able to just select the right answer without doing any work. It just means that you're trying to use, a number of different techniques. Here for number 4, the solution to the equation lies between which of the following intervals. Now, because 3 and 5 have no like bases, you would not be able to use that strategy. You could use a graphing calculator strategy and then put one of them in y1, one of them y2, and then look for the point of intersection. The other option, algebraically, we've only done it a couple of times, and since we've only done it a couple of times, I think it's worth doing in this instance. So because of the fact that you have base 3 and base 5, normally we would take the log of both sides, but because we don't know what base to choose, we're actually going to choose the ln of both sides. So the ln of 3 to the 2x equals the ln of 5 to the x minus 1. Then you're allowed to use the properties of logs, and you're going to move the exponents down to the front. So 2x times the ln of 3 equals x minus 1 times the ln of 5. On the right-hand side, you are going to distribute. So 2x ln of 3 equals x ln 5 minus ln 5. You now have to put all the x's on the same side, and so I'm going to put them all on the right side. So I'm going to move the ln of 5 to the left, which makes it positive, which means I'm going to get x ln 5 minus 2x ln 3. I'm going to factor out an x, leaving me with ln 5 minus 2 ln 3, which means that when I solve for x, I'm going to get the ln of 5 divided by the ln of 5 minus 2 times the ln of 3. So that would be the exact value. And again, that could be an answer if there was no calculator available to you. But because there is a calculator available to you, you would simply want to calculate that. If you were to calculate that very carefully, again, using parentheses as needed, you would get that that is equal to negative 2.738. You would then have to select between which two numbers is that between, and hopefully you'd be able to identify correctly that that is between -2 and -3. Here in number 5, this is a very, very, very popular type of question, giving you 3 choices and then asking which is true. So at this point, maybe you developed your own strategy. The truth is you really have to test each one. I personally like to draw a check mark if it's true, an X if it's false. You can kind of do what works for you, but you do have to check each one in the scenario. So of these 3 choices, which could potentially be the graph to the right? So taking a look, we see that there's a vertical asymptote at x equals 2. And then the fact that it is facing to the left, the fact that it is to the left of the vertical asymptote means that the domain has to be less than 2. It means that potentially there was a reflection over the y-axis because the log normally points to the right. So lots of different things to kind of go in with. I'm going to start with the fact that in order to find the equation of the vertical asymptote, you're going to set each of these arguments equal to 0. So if I set x minus 2 equal to 0, I'm going to get x equals 2 for the vertical asymptote. If I set negative x plus 2 equal to 0, I'm going to get x equals 2 for the vertical asymptote. And if I set 6 minus 3x equal to 0, I'm going to get 6 equals 3x, which means I'm going to get x equals 2. So just to be clear, if you check them in terms of vertical asymptotes, you can see that they all would technically be part of it. But now you have to make sure that each of them would in fact face to the left. You can either do that using a reflection or using the domain. If you're going to do it in terms of a reflection, again, you would have to know that a log normally in its parent form faces this way. So because of the fact that it's facing the other direction means that there was a reflection over the y-axis, which means if there was a negative inside, that is a case where that could be the answer. So you could use that to tell you that it's 2 and 3. You could also do it in terms of domain. If you were to go back and take each of these arguments and set them greater than 0, that would tell you whether the domain was to the left or to the right. And you're going to get the same conclusions that it's not correct for 1, the domain would be to the right. It is correct for 2, not only because of the domain, but also the y-axis reflection. Similarly for number 3, and 2 and 3 only means it has to be choice E. All right, so let's go ahead and finish up with one free response question. And so we've seen several of these now in the last couple of weeks, and we'll see a ton more throughout the remainder of the year. Seems like you guys are getting better at these, at trying to, again, target your answers. Don't just answer the question, but also say something that shows the reader that you understand what the question is asking. So here, biologists can estimate the age of an African elephant based on the length of an elephant's footprint using the L function that's given here, where L of t is the length of the footprint in centimeters, and t is the age of the elephant in years. And then you can also estimate the age of an elephant based on the diameter of the pile of elephant dung given by the D function, where D is the diameter of the pile of dung in centimeters, and T represents the age of the elephant in years. So 2 different functions. The truth is when it comes to the AP test, it's more likely than not that they would actually give you those functions and ask you to apply them as opposed to having you find them on your own. Because if you did find them on your own and you found them incorrectly, everything that followed would be incorrect. So here in part A, find the value of L0. L of 0, using the correct units of measure, explain what this value represents in the context of the problem. So again, not only finding the calculation, but also explaining it in the context of the problem. So just be extra careful here. Make sure you're using the correct function, the L function. So L of 0 is equal to, and then show that you understand how to do that. So 45 minus 25.7 e to the negative 0.09 times 0. Again, you would have to show the AP grader that you understand what it means to plug in 0. Then as far as what other work you showed them, it wouldn't really matter. I'm just going to show you. So 45 minus, you would get e to the 0, which of course would be 1. So 45 minus 25.7 would equal 19.3. And again, that would be worth 1 point, showing them that you know to plug in 0 to the L function and then correctly calculating it to be 19.3. And then a second point would be available if you actually explained it correctly. So what this means is that at birth, or you can say age 0, the length of an elephant footprint is approximately 19.3 centimeters. So again, just to be clear, it's not that your answers have to be long or that they have to, be wordy. They just have to kind of hit the exact key phrases and keywords that they're looking for, which in this case is not only to correctly calculate 19.3, but then also to accurately explain it. So here in part B, it asks you now to find the value of d of 15, and then again, explain what this value represents in the context of the problem. So in order to get one of the points, you would have to show that you correctly can find d of 15. So d of 15 is equal to, now this is a much more complicated equation, so you'd want to be extra cautious when you're plugging it into your calculator. So e to the negative 0.093 times 15 minus 0.457. Okay. And again, they would never expect you to really come up with this equation on your own. They would assume that you're not an expert in elephant dung, although, I don't know what you guys do on your free time. So I guess that's up to you. But show that you understand that you're plugging 15 into the equation. And then again, in terms of how much calculation you actually show, it would vary. But that would be equal to, if you did it very carefully, 13.854. So again, to get that second point, you would have to say at age 15, the diameter of a pile of elephant dung would be approximately 13.854 centimeters. And again, you should round to 3 decimal places where appropriate. In part A, there was no further rounding. So if it's just zeros, you don't have to say that, although you certainly could. So A and B, probably the most straightforward parts of the question, just making sure you can plug it in, calculate, and explain. So hopefully that is not too shabby. Let's go ahead and look at C and D. So during the first 50 years of an elephant's life, will the diameter of its dung pile ever be the same as the length of the footprint? If so, at what age? Explain how you arrived at your answer by investigating the graphs of L and D. So if they're telling you to investigate the graphs, it's more than likely they'd want you to use a graphing utility, since if you had to graph each of those, it would take a while and it would be very inaccurate, especially if you are trying to do it for the first 50 years. So this would be a case where you'd want your graphing calculators. So I'll go ahead and show you mine. So as I pull up my graphing calculator here, I noticed that I plugged the L function into y1, and I plugged the D function into y2, and I took extra care to make sure that I plugged it in correctly. Remember, if this was the AP test, you'd only get one shot at answering each question. So take your time, check your work. Notice, of course, that I'm using X instead of T, since there is no T variable. So from here, once I plug in both of those equations, if I simply try to press graph, I'm at my normal window, the 10 by 10. Because of the fact that they're telling you to investigate the first 50 years of the elephant's life, you have to make sure you're looking at the right thing. So I'm going to go ahead and press window. Because of the fact that I'm only trying to look at the first 50 years, I'm going to start at 0, since obviously you can never have a negative age. Then I'm going to go ahead and say 50 years. In terms of the Y values are talking about the centimeter length of the dung pile and also of the footprint. So how high could that possibly be? Yeah, I'm not really sure. I'm not really an elephant expert. Let's go ahead and say 50 centimeters, maybe being the maximum. And man, I hope I never come across that. But let's go ahead and use that as our point of reference. And then if I press graph again, notice that you should see what's happening here. So that is showing you both of the functions. Notice that these are both, exponentials that have negatives in the exponent, and then also negatives in front of the E. So that means you started off with a growth, then you had 2 reflections, which is why the graphs both look like such. Notice that for this window from age 0 to age 50, those two graphs don't ever intersect. The blue one is always much larger than the red one. So that means that they're never, ever, ever going to meet, and that's going to allow us to go ahead and answer the question. So in terms of answering the question, first, I'm going to say that no, they're never going to be equal. So, oops, go back to my pen. So the diameter of the dung pile will never equal the length of the elephant footprint. And again, you don't have to say it in the exact words that I'm using as long as you're getting the general idea. So point number 1 would be to make sure you explain that they're never going to be equal. And then you should say, so we'll never equal the length of the elephant footprint. And then how do you know that? So I would say, according to the graphs of L and D. So I looked at the two functions. That's how I decided they're never going to be equal. Then further, what is it exactly that led you to that conclusion? So something like when graphed, a little bit of room here, when graphed on the interval from t equals 0 to t equals 50, the graphs never intersect. So again, you can say that in your own words. Doesn't have to be the exact verbiage that I'm using. So again, the key points here is you would have to highlight the fact that they're never going to meet and that you did in fact look at the graphs as it told you to. You would have to indicate the fact that you looked on the appropriate interval, and you would then have to conclude again that you know that the reason why they'll never be the same is because they never intersect. So doesn't matter the length or the wordiness as long as you hit those key values. Last but not least, solve the equation L of t equals 36, and then you're going to go ahead and solve it to the nearest whole number. So again, the normal conventions are to round to 3 decimal places unless otherwise noted. So here's a place where it's otherwise noted. You have to use the correct unit of measurement, explain what it means in the context of your problem, and then you also have to make sure that you are showing your work. So if we're solving the L equation, we're going to set the L equation equal to 36. So 45 minus 25.7 e to the negative 0.09t. So now let's go ahead and solve away. So I'm going to start by subtracting 45 by both sides, which is going to give me negative 9 equals negative 25.7 e to the negative 0.09t. I would then go ahead and divide both sides by negative 25.7. If I divided a negative 9 by a negative 25.7, I would get a positive 9 over 25.7 equals e to the negative 0.09t. And again, you really should not round anything until the final step. So don't calculate 9 over 25.7. Just leave it as such. Just so you know, you would actually get a point for getting that far. Isolating the e would be enough for you to get 1 point. Then to get a second point, you'd have to actually go ahead and solve it now. So from here, to get rid of the e, you'd have to take the ln of both sides. So the ln of 9 over 25.7. On the right, you're going to take the ln of e to the something, which that would cancel out to just be the something. So negative 0.09t. To get t all by itself, you would have to calculate the ln of 9 over 25.7, and then you'd have to divide that by negative 0.09. If you went ahead and did that very carefully and then calculated it, you would get 11.659. And again, it told you to round to the nearest whole number, which would be 12. So you'd get a second point for correctly doing that. And then last but not least, the explanation. So at age 12, an elephant has a footprint of 36 centimeters. So again, it's not necessarily that the questions are going to be difficult. They just want you to answer the question that's being asked, and they want to make sure you address every single thing in the problem. That's only 2 sentences in the problem, but they're really asking you for several different things. So again, you just have to be extra careful, making sure that you are, in fact, getting each different part. So in addition to having my work there, I also have for you a copy of the actual rubric. I will provide these to you at the conclusion of, when I grade things, just in case you want to see it. So again, this is what it would look like to the AP grader. They would separate it into the different sections, A through D, and they would tell you where each of the points were available. So feel free to look at this. In tonight's homework, I'll also have a copy of the rubric. On the assessment, I'll have a copy of the rubric as well. So the more frequently you kind of see these, hopefully the more familiar it becomes. So thanks very much for tuning in, guys, and we will catch you next time.